yung bilang ng imposter eh.
Okay, go lang.
Oh shit!
Hi, Cristel ba? Hirap naman yun. Uy! Nag-double kill sila!
Perfect.
7.
So we're back, guys. 77 is 2.2 times 77, 140.
So, hello guys, and we're back on our series of Programming with Me, and this is episode 4. Yeah, episode 4. Today we're using Python, and my friend just sent me a new problem for us to do. Actually, this is from her seat work, I guess, and she asked me for help, so might as well do something with it. Let us record how are we going to solve this problem that she gave us. Okay, so here we have, the problem that she sent us. Okay, a narcissist number is an n-digit number that is equal to the sum of the n power of its digits. Something nd. For example, 153 is a narcissist number because 1 times 1 times 1 plus 5 times 5 times 5 plus 3 times 3 times 3 equals to 153. And 1634 is a narcissist number equals to 164. All one-digit numbers are narcissist numbers. Here are the narcissist numbers from 1 to 10,000. Okay. So now, what are we supposed to do with this program is that... Wait, what? Oh. Sorry about that. Okay, it's my cabinet. It's just my cabinet. Anyways, what are we supposed to do is we should complete the following program that asks for input x and print all the narcissist number from 1 to x. Okay. We're just going straight through the program since this actually takes a while to put some flowcharts with it. And so we ask for integer x, in which, if I remember, x equals input int, then inside input enter integer x. I'm not sure if I'm doing it right. In the meantime, we must save this so that it can correct us on what are we doing. Oh no, I cannot see here. There we go. And so for our Python, we have test1.py. There. We ask for integer x, and now what are we supposed to do? We should ask... It only tells us to ask for integer x. Oh no, there. What? There. And so from there, I think from integer 1 to x, guess we can just use for loops. For I in range 1 x plus 1. So what is this for I in range x plus 1? Okay, so for loops is a loop that checks from this first number, here we go, till this number minus 1. So that's why I put x plus 1, because if it will check from 1 to x. Because if I remove this, we are going to check from 1. Wait, I don't think you can see it. There. We are only going to check from 1 to x minus 1. There. That's why I put x plus 1. Because it said it checks from 1 to x, instead of x minus 1. So first of all, we must know how many digits we have in in x. So let us say we have, we are just going to use I for it. So we have our current number equals to I. That's our current number. And for us to check it, how should we do this? We can actually divide the number by 10 and find current number is okay, so digits, number of digits how do you like that? Yeah, let's just put digits equals 0. So our count is digits plus equals to 1 there. So for our while, I think we can just do current. What I'm planning here is less than 0, less than 0, less than 0. Yeah. What I'm planning here is that it will continuously divide it by 10. So let's say cur, we are going to use the floor sign, cur floor of 10. If we have cur floor of 10, cur equals cur floor of 10. Cur. Yeah, I think that will do. So let's say we have 15 floor of 10 equals to 1, then floor of 10 equals to 0. So yeah, it satisfies. We have 2 digits and our current becomes 0. From there, I think we can just restart. So we have current back to I. Anyways, from there we have the digits. Now we have to know which what do you call this? How are we going to find the product that we are going to put in our sum? So I'll name our sum A equals to 0. Then product. I think for our product we can just, what do you call this? In a sense, we have n digits. So if let's say we have 3 digits and we have 153, 5 times 5 times 5 can also equal to 5 raised 3. So for our product, I think we can just do it for, what do you call this? Product equals to how are we going to do this? Okay, for our product, what are we going to do here is that we can just raise a number to, what do you call this? Raise a number to digits. Yeah. So from there, how do we find the number? We can just get the remainder, I guess. Let's say 153, the remainder of 10. So if we have a remainder of 10, we will have 3. Then for the next we'll have 5. Then for the next we'll have 1. So I guess we are going to put here modulo. Modulo 10. No, 10. Raised to number of digits, so we have the product and sum. Yeah, sum A equals to product. No, prod plus sum. We can just plus equals to prod, I guess. So from there, our current should not return to I, and our sum should not return to 0. So we'll have a while loop here. While, how should we do this? We'll put our current while cur. Oh, I think we should do this first. Cur equals, I think we can just do this thing again. Cur divided by 10. Discounts the number and less than 0. I think that will do. Then while cur is less than 0, less than 0, less than 0. Then if we must put an if statement. However, we are lacking some of the things here. Okay. While now what we must put is if I is equal to sum A, print sum A. Sum A. I think that will be enough for our code. Yeah. So from here I am going to test this CMD. I'm going to use command prompt. So we have change directory, desktop, Python 3.8. That's the name of my folder, and programs. Oh no. I think this is case sensitive. I think. And this should be on capital B. What? Oh. Now I remember. It should have a space there. Then test1.py. Oh. I think we should do this. Yeah. I have a little bit of error in my syntax because, as you have seen on the past episodes, I'm currently using C. I just did this because I was helping one of my friends on her, what do you call this? ComSci course. Let's see, have 30. Oh no, why does it not print? Sum A plus equals to prod. Now what's the problem? Well, I think we should print sum A beforehand. Print sum A. Oh no. Have we, what do you call this? Have we saved it yet? We should put 10. Oh! What? It says here the sum A is equal to 0, but why? Sum A plus prod. Should this change? Then, yeah, it doesn't work. Sum A equals to 0 now. While cur is, oh, it should be while cur is greater than 0. That logic error though. That logic error. So here we are. So before I started this video, the problem was this one. I put it so that cur is less than 0, which is, it's supposed to be while cur is larger than 0. So yeah, I think this should work. Let's say we have 30, oh yeah, and 153. 10,000. Okay, so I guess we got the gist of it. And now I'm going to what do you call this? Analyze for you the code that we have made. I actually just read on this code since my class already asked for help for this. Anyways, so what our code is was, okay, from here I think you could understand. Let's say we have 153. So our code, this code for I in range 1, it checks, it loops, it loops from 1 to 153. Okay, so we have we made current digit equals to I because we cannot change I, and our goal here is for our cur to be a counter, so that while cur is having a floor function, floor operator of 10. So let's say we have 153. 153. Or I made it wrong. So we have we have 1, Then from here, our for function, it removes a digit. So it becomes 15. Then from 15, we add another 1, and this becomes 1. Then cur is still 1 and is still larger than 0. Yeah, it inputs 1, then plus 1, so we have 3. And what do they call this? 1 becomes 0. From there, we have current digit equals to 3. Yeah, current digit equals to 3. Digits. Digits equals to 3. From there, we used our cur. We reassigned cur to be a new counter. That's why we reset it to the digit I. So this time, while we have sum A 0, I'll just separate this. So we have, let us say, cur equals to 153. So our product becomes cur modulo of 10 becomes, it releases what they call this, the remainder. So 153 divided by 10 is 15 remainder 3. So we have 3 raised to our current digits. So we have the value of digits equals 3. And from there, our current becomes, cur equals to 15. Same logic as this one. It becomes a counter. And for our sum A plus product, so we have 0 plus 9, which is 3 raised to 3. 9. From there, we have our current sum of 9. Sum A equals 9 plus something. From there, we input 15. And it becomes 5 raised to 3. 125. So 125. So from there, it becomes 134. Yeah. And our current becomes, it becomes 1. Current becomes 1, which is still larger than 0. Remainder equals 1 raised to 3. Wait. I made a mistake, sorry. It should be 27. Because 3 plus 3 is 9. 3 times 3 is 9, and multiply it by 3 is 27 plus 125. So we have here, 152. And our current equals to 1. This becomes 0. And we add 1. Because 1 raised to 3 is 1. So it becomes 153. Our sum A equals to 153. Now, if our current I is 153, which is the current number it is checking, it prints the number sum A. So yeah, that's the gist on how we did this. I think that will be all for this episode. This will be a short one, and for the next episode, I'm going to try to minimize the, what they call this, the time lapse, since it's kind of useless. You're just watching me study, watching me make my code. So I guess I'm just going to do the code, then I'm going to kind of memorize, I guess, or just, what they call this, just understand it. So in real time, I can recreate the code while I'm reading the problem. And I think if I'm going to make flowcharts, I'm just going to do them beforehand so I can explain to you immediately what are we going to do with it. So yeah, I guess that will be all for this video, and see you all on the next video. Please hit the like button, subscribe button, and bell notification, since I'm going to try to start uploading more videos eventually. For now, I'm just going to try to do every 3-4 days, every week. And so yeah, this is the my code for finding the a narcissist number. I guess that will be all for now, and see you in the next video. And I hope you enjoyed it. Bye bye.